Hi everyone, it's me, Teacher Jeanne, and in this lesson you will learn about basic concepts of probability. At the end of this lesson, you are expected to define experiment, outcome, sample space, and event. Second, illustrates experiment, outcome, sample space, and event. And for the last, appreciate the values and importance of using the knowledge about experiment, outcome, sample space, and event in real-life situation. Now, we have here the branch of mathematics that deals with uncertainty is probability. Probability is a measure or estimation of how likely it is that an event will occur. Activities such as tossing or flipping a coin or picking a card from a standard deck of cards without looking, which could be repeated over and over again and which have well-defined results, are called experiments. The results are called outcomes. When you roll a balanced die once, there are 6 possible outcomes, which are 1, 2, 3, 4, 5, or 6. Getting an odd number includes 3 outcomes. These are 1, 3, and 5. Getting an odd number is called an event. An event is a subset of a sample space of an experiment. More examples are letter A, getting a 3 tails when flipping a coin thrice. Letter B, choosing a jack from a deck of cards or any of the 4 jack. And for letter C, getting an odd number or 1, 3, or 5 when rolling a die. Probability is a value between 0 and 1 inclusive. Probability may be given in fraction, decimal, or percent. 0 in probability means 0%, that is impossible to happen, while 1 is 100%, which means the event is certain to happen, while 1/2 or 50% or 0.5 means an event is either as likely or as unlikely to happen, or that is considered even chance. The event between 0 to 1/2 is unlikely to happen. Remember, the more closer it is to 0, the more unlikely the event is to happen, or that is considered less chance. For example, the probability is 1/4 or 25% or 0.25, or we also consider 2 in 6 chance. While if the event is between 1/2 to 1, the event is likely to happen. The closer it is to 1, the more likely the event is to happen, or we have the bigger chance. For example, the probability is 3/4 or 75% or 0.75, or also we considered 4 in 5 chance. Now let's have activity 2. Direction. Tell whether each event is certain, impossible, or possible. For number 1, a mother will give birth to twins. That is possible. Some mothers have twins. For number 2, tamarind is sour. That is certain. For number 3, you will go sunbathing tonight. That is impossible, since there is no sun at night. For number 4, if you dip your hand in water, your hand will get wet. That is certain. For number 5, June comes after July. That is impossible, because June 1st before July. For number 6, sugar dissolves in water. That is certain. For number 7, a dog will lay eggs. That is impossible. For number 8, a snake will swim in water. That is possible. For number 9, a carabao will climb a tree. That is impossible. For number 10, you will make it to the list of top 10 students in your class. That is possible. Now, in flipping a coin, we have 2 possible outcomes. We have the head and we have the tail. Now, in rolling a die, we have 6 possible outcomes. We have 1, 2, 3, 4, 5, and 6. And in a deck of 52 cards, we have 52 possible outcomes. We have 13 diamonds, we have 13 clubs, we have 13 hearts, and we have 13 spades. And take note also, in 52 cards, we have the 4 aces, we have 4 jacks, we have 4 queens, and we have 4 kings. And the jack, queen, and kings are what we call the face cards. And these are the set of possible outcomes of an experiment, which also known as the sample space or the probability space. And each individual outcome is what we call the sample point. For example, we have the experiment flipping 2 coins. The sample space is we have the head, tail, head, and we have the tail. The number of possible outcomes is 4, and the sample point is we have the tail. Another experiment is rolling a die. We have 1, 2, 3, 4, 5, 6. So we have 6 possible outcomes. And sample point is 3. Another experiment is rolling a coin and a die simultaneously. So we have the sample space, head 1, head 2, head 3, head 4, head 5, head 6, tail 1, tail 2, tail 3, tail 4, tail 5, and tail 6. So we have 12 possible outcomes. And sample point is head 3. And for the last is drawing a card from a deck of 52 cards. We have 13 diamonds, 13 hearts, 13 spades, 13 clubs, which consist of ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, and king. And the number of possible outcomes is 52. The sample point is king of hearts. Now take note, king is not a sample point because there are 4 king, which are 4 different sample points in a deck of cards. And sample point is considered individual outcome. Now let's do more. Study each experiment carefully. Write the sample space and the total number of possible outcomes on the space provided. Now for letter A, spinning the wheel shown assuming that the arrow will never fall on the lines separating the 6 sectors. For the sample space, we have 2, 4, 6, 8, 10, 12. For the number of possible outcomes, we have 6. For letter B, drawing a card at random, form a deck of 10 identical suits labeled 6 to 15. The sample space are 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. The number of possible outcomes is 10. And for the last, letter C, tossing a standard octahedral or 8-sided die. We have the sample space 1, 2, 3, 4, 5, 6, 7, 8. So the number of possible outcomes is 8. Now, let's discuss the probability of an event. At the end of this lesson, you are expected to find the probability of a simple event. Now, before we proceed, let's have a recall. For activity 1, we have the experiment, direction. In the given experiments, supply the sample space and the event. For number 1, draw a card from 52 playing cards. For letter A, determine the sample space. So we have 13 clubs, 13 spades, 13 hearts, and 13 diamonds. For letter B, find the event that a diamond is drawn, we have 13. An ace is drawn, we have 4. A king or queen is drawn, we have 8. For number 2, a bag contains 10 blue balls, 20 yellow balls, 30 white balls, and 35 red balls. For letter A, determine the sample space. We have 10 blue balls, 20 yellow balls, 30 white balls, and 35 red balls. For letter B, find the event that a ball is drawn. Yellow, we have 20. Blue, we have 10. White or red, we have 65. Now let's have here the simple events. Any event consisting a single point of a sample space is known as simple event in probability. For example, in rolling a die, if the sample space is 1, 2, 3, 4, 5, 6 and event is 3, then E is a simple event. The probability of simple events is finding the probability of a single event occurring. We will use the formula the number of favorable outcomes over the number of total outcomes. After calculating this probability, your answer will need to be in simplest form. Now, for you to understand, let's have the following examples. For number 1, a color wheel is divided into 10 equal parts. When the pointer is spun, what is the probability that will stop at letter A, 7? Now, to find that answer, we are going to use the formula. The probability of an event is equal to the number of favorable outcomes, or N of E, divided by the number of possible outcomes, or N of S. So, for letter A, the probability probability of 7 is equal to 1 out of 10. So 1 is the favorable outcomes and 10 is the number of possible outcomes. For letter B, the prime numbers are 2, 3, 5, and 7. So the probability of a prime number is 4 out of 10 or 4 over 10. 4 and 10 have a common factor which is 2. 4 divided by 2 is 2. 10 divided by 2 is 5. So we have 2 over 5. So don't forget to write it in the simplest form. For letter C, all numbers in the wheel are less than 11. So the probability of number less than 11 is 10 over 10. And 10 divided by 10 is equal to 1. For letter D, the numbers greater than 7 are 8, 9, and 10. So the probability that it will stop at a number greater than 7 is 3 out of 10 or 3 over 10. And that is already in the simplest form. Next, for letter E, what is the probability that it will stop at number between 1 and 8? So the numbers between 1 and 8 are 2, 3, 4, 5, 6, and 7. So therefore, the probability of a number between 1 and 8 is 6 out of 10 or 6 over 10. 6 and 10 has the greatest common factor which is 2. So 6 divided by 2 is 3 and 10 divided by 2 is 5. So we have 3 over 5 as the simplest form. For letter F, the even numbers are 2, 4, 6, 8, 10. So the probability that it will stop at even number is 5 over 10. 5 and 10 has the greatest common factor which is 5. So 5 divided by 5 we have 1 and 10 divided by 5 is 2. So the simplest form is 1 over 2 or 1/2. For letter G, the square numbers are 1, 4, and 9. So the probability that it will stop at a square number is 3 out of 10. And that is already in the simplest form. For letter H, there is no negative number. So this is an impossible event. So the probability that it will stop at negative number is 0 out of 10 or 0 over 10. And 0 divided by 10 is equal to 0. Now let's have example number 2. A fair die is rolled. For letter A, write down the sample space. So we have 1, 2, 3, 4, 5, 6. For letter B, find the total number of possible outcomes. So the n of S is 6. So we are going to use the formula, the probability of an event is equal to the number of favorable outcomes or n of E over the number of possible outcomes or n of S. So the probability of 4 is 1 over 6. We only have one favorable outcome out of 6 possible outcomes. Second, the odd numbers are 1, 3, and 5. So the probability of getting odd number is 3 over 6. 3 and 6 has a common factor which is 3. So 3 divided by 3 is 1 and 6 divided by 3 is 2. So the simplest form is 1/2 or 1 over 2. For the third one, we have the multiples of 2 are 2, 4, and 6. So the probability of getting a multiple of 2 is 3 out of 6 or 1 over 2 or 1/2. And for the last, there is no number greater than 6. This is an impossible event. So the probability of getting a number greater than 6 is 0 out of 6 or 0. For example number 3, 15 identical cards are labeled 1 to 15 and placed in a box. Find the probability that a card drawn at random may be, for letter A, the multiples of 5 are 5, 10, and 15. So the probability that a card is a multiple of 5 is 3 out of 15 or 3 over 15. 3 and 15 has the greatest common factor which is 3. 3 divided by 3 is equal to 1 and 15 divided by 3 is 5. So we have 1 over 5 or 1/5 as the final answer. For letter B, the numbers less than 8 but greater than 3 are 7, 6, 5, and 4. So the probability that a card drawn at random may be a number greater than 3 but less than 8 is 4 out of 15 or 4 over 15. For letter C, the factors of 15 are 1, 3, 5, and 15. So the probability that a card drawn at random may be factor of 15 is 4 out of 15. 4 and 15 have no common factor, so that is the final final answer. For letter D, the numbers divisible by 2 and 3 are 6 and 12. So the probability that a card drawn at random may be divisible by 2 and 3 is 2 out of 15. And that is already in the simplest form. For letter E, the numbers have 1 on it are 1, 10, 11, 12, 13, 14, and 15. So the probability that a card drawn at random may be has a number 1 on it is 7 out of 15 or 7 over 15. And that is already in simplest form and final answer. For example number 4, there are 20 marbles in a container. 4 blue marbles, 5 yellow marbles, 8 green marbles, and 3 red marbles. What is the probability that a marble picked is yellow? So again, we are going to have the number of possible outcomes is 20. And the formula is probability of an event is equal to the number of favorable outcomes divided by the number of possible outcomes. For letter A, the probability that the marble pick is yellow, we have 5 over 20 or 5 out of 20. 5 and 20 has the greatest common factor which is 5. 5 divided by 5 is 1 and 20 divided by 5 is 4. So we have 1 over 4 or 1/4 as the final answer. Or in decimal, that is 0.25 or in percent, that is 25%. For letter B, the probability that the marble pick is red, we have 3 out of 20 or 3 over 20. In decimal, that is 0.15 or 15%. For letter C, the probability that the marble pick green marbles, we have 8 out of 20 or 8 over 20. 8 and 20 has the greatest common factor which is 4. So 8 divided by 4 we have 2. 20 divided by 4 is 5. So we have 2 over 5 or 2/5. And that is equivalent to 0.4 or 40%. For letter D, the probability that the marble picked blue marbles, we have 4 out of 20 or 4 over 20. 4 and 20 has the greatest common factor which is 4. 4 divided by 4 is we have 1. 20 divided by 4 we have 5. So 1 over 5 or 1/5 or 0.2 in decimal or 20%. For example number 5, suppose you draw one card at random from a deck of 52 playing cards. What is the probability that the card pick is? So the number of possible outcomes is 52 and we have the formula probability of an event is equal to the number of favorable outcomes over the number of possible outcomes. Now for letter A, the probability that the card pick is aces, we have 4 out of 52 or 4 over 52. 4 and 52 has the greatest common factor which is 4. 4 divided by 4 is we have 1 and 52 divided by 4 is 13. So we have 1 over 13 as the simplest form. For letter B, the probability that the card pick is face cards, we have 12 out of 52. So 12 and 52 has the greatest common factor which is 4. 12 divided by 4 is 3. 52 divided by 4 is 13. So we have 3 over 13 as the final answer or the simplest form. For letter C, the probability that the card pick is suit of hearts, we have 13 over 52. And the greatest common factor of 13 and 52 is 13. So 13 divided by 13 is 1 and 52 divided by 13 is 4. So we have 1 over 4 or 1/4 as the simplest form. For letter D, the probability that the card pick is not a red card, we have 26 over 52. 26 and 52 has the greatest common factor which is 26. 26 divided by 26 is we have 1 and 52 divided by 6 is we have 2. So we have 1 over 2 or 1/2 as the simplest form. For letter D, the probability that the card pick is not a diamond, we have 39 over 52 or 39 out of 52. And the greatest common of 39 and 52 is 13. So 39 divided by 13, we have 3 and 52 divided by 13 is we have 4. So we have 3 over 4 or 3/4 as the simplest form. For example number 6, in a class of 40 senior high school students, 18 of them want to become teachers, 12 engineers, and 10 police officers. Find the probability of these students becoming professionals in their chosen fields. So we have the number of possible outcomes is 40, and we have the probability of an event is equal to the number of favorable outcomes divided by the number of possible outcomes. For letter A, the probability of these students who want to be a teacher is 18 out of 40 or 18 over 40, and the greatest common factor is 2, so we have 9 over 20 as the simplest form, or in decimal that is 0.45 or 45%. For letter B, the probability of these students want to be an engineer is 12 over 40 or 12 out of 40, and the greatest common factor of 12 and 40 is 4. So we have 3 over 10 or 3 out of 10 as the simplest form, or in decimal that is 0.3 or 30%. For letter C, the probability of these students want to become a police officer is 10 over 40 or 10 out of 40, and the greatest common factor is 10, so 10 divided by 10 is 1, and 40 divided by 10 is 4, so we have 1 over 4 or 1/4 as the simplest form, or 0.25 in decimal or 25%. And for the last, the probability of these students who don't want to be a teacher is 22 out of 40 or 22 over 40, and the greatest common factor is 2, so the simplest form is 11 over 20, or in decimal that is 0.55 or 55%. For example number 7, each of the letters of the word Philippines is written on a card. The 11 cards are shuffled and placed upside down on the table. What is the probability that a card picked at random shows the letter P, the letter S, a vowel, a consonant? So the number of possible outcomes is 11, and we have the formula the probability of an event is equal to the number of favorable outcomes over the number of possible outcomes. For letter A, the probability that a card picked at random shows the letter P is 3 over 11 or 3 out of 11. So in decimal, that is 0.27 or 27%. For letter B, the probability that a card picked at random shows the letter S is 1 over 11 or 1 out of 11. In decimal, that is 0.09 or 9%. For letter C, the probability that a card picked at random shows a vowel, we have 4 over 11. So we have 3 I's and 1 E. So that is 4 out of 11 or 4 over 11. In decimal, that is 0.36 or 36%. For letter D, the probability that a card picked at random shows a consonant, we have 7 out of 11, which is the remaining if you are going to remove the 4 vowels. So in decimal, that is 0.63 or we have 63%. For example number 8, what is the probability that a day of the week drawn at random starts with T, has more than 6 letters, has the letter E in it, and for the last ends in Y? So again, we are going to use the probability of an event is equal to the number of favorable outcomes over the number of all possible outcomes. For letter A, the day of the week that starts with letter T are Tuesday and Thursday. So the probability is 2 over 7 or 2 out of 7. So the number of favorable outcomes is 2 and the number of possible outcomes is 7. For letter B, the day of the week that has more than 6 letters are Tuesday, Wednesday, Thursday, and Saturday. So the probability that a day of the week has more than 6 letters is 4 over 7 or 4 out of 7. For letter C, the day of the week that has letter E in it are Tuesday and Wednesday. So the probability is 2 over 7 or 2 out of 7. And for the last, all of the days of the week ends in Y. So the probability is 7 over 7 or 7 out of 7 or 1. Now take note the probability rules. For number 1, the probability of an event is a number, either a fraction, a decimal, or a percent from 0 to 1. Example, the weather forecast shows a 70% chance of rain. For number 2, the probability of an empty set is always equal to 0. In symbol, it can be written like this. The notation stands for the empty set, which is a set that contains nothing. An empty set is an event which for sure does not happen. For example, when a single die is rolled, find the probability of getting an 8. Hence, probability of 8 is equal to 0 over 6 or 0. For number 3, if an event is sure to happen, then the probability is 1. For example, when a single die is rolled, what is the probability of getting a number less than 7? Since all the outcomes 1, 2, 3, 4, 5, 6 are less than 7, the probability of a number less than 7 is 6 over 6 or 6 out of 6 or 1, or can be written as 100%. Now, it's your turn. Do it yourself. Comment down below your answers. Happy learning! Thanks for watching. Please like and share. And don't forget to subscribe on my channel and click the bell button so that you will be notified whenever I'm going to upload a new one. Maraming salamat!